Alright, hey there again. This section is called fractions on steroids because it's a little bit tougher than the fractions on fractions that we did in class. So let's go ahead and go with it. Okay, we're going to take this example and copy it on the next page. Alright, so here we go. Example 1, and I want you to do a problem like this, similar to this, towards the end of the class here. So let's say I have 3 over x plus 2 minus 3 over 5. Okay, all over x minus 2. If I do direct sub on this limit, I'm going to get 3 over 2 minus, 3 over 4. Well, that should be a 4, shouldn't it? Whoops. 3 over 4 minus 3 over 4. Okay, over 0. Well, that ends up being 0 over 0. Now, in this situation, with calculus, when we get 0 over 0, we get happy. Okay, when we do work. Now, what is the ambiguity here? What is the complexity that's causing a problem? It's the fraction inside the fraction. That's causing the problem. So our job is to get rid of the fraction inside the fraction. So here we're going to get common denominators. 3 over x plus 2 minus 3 over 4. So we're going to give this denominator 4. And we're going to give this denominator an x plus 2. Okay, and then we're going to leave that denominator alone, and so that's going to give me 12, and that's going to distribute. So limit Now you might be wondering, why didn't I distribute this negative right here? Well, I didn't want to. I decided to leave it where it was. Okay, I just decided to distribute what I had. So now I'm going to combine though, and when I combine these two fractions to make one, I am going to distribute the negative because essentially there's a parentheses there, right? So 12 minus 3x minus 6. I forgot my x minus 2. Now, so we continue to plow ahead mathematically here until we reach the fact that, 12 and negative 6 make 6, so you end up with 6 minus 3x over 4x plus 2. Okay, so there's not over x minus 2. So right here, what we need to do is see that there's something going on right here. There is something about to happen. Alright, so I always like to make things look like each other. So how can I make this look like this? How can I make this look like this? Well, I can take out a negative 3. If I pull out a negative 3 on top, 6 divided by negative 3 is negative 2. Pulling out a negative 3. Negative 3 divided by negative 3 is positive 1x. And the 4 and the x plus 2 stayed the same. Okay. And then you have x minus 2 on the bottom. So there we are. Okay. That just became that. Well, what do I notice I can do here? Well, I can make this look more like this. Now you'll see why I'm doing this in a second. So we're back to the limit notation. Limit. Let me zoom out just a tad bit. As x approaches 2, negative 3, x minus 2, switch them up, 4, x plus 2, x minus 2. Now, remember this is called your major division, okay? So this is being divided by that. Now, so it is being divided by x minus 2. You're dividing something by x minus 2. Remember, anytime you divide, you can always multiply it by the reciprocal. Times 1 over x minus 2. So that's what we're going to do. That's what we're going to do to that. And here it is. I just took that, instead of dividing, now I'm multiplying by the reciprocal. Okay, always have an extra sharp pencil ready. These now cancel. Limit as x approaches 2 is negative 3 times 1, which is negative 3, over 4 times x plus 2 times nothing because it's gone. Now I can direct sub, so negative 3 over 2 plus 2 is 4, times 4 is 16, negative 3 over 16. Voila. Okay, so in the essence of time now, I'm just going to give you the example I want you to do. Okay, panning out, you may pause and do the example, similar to what I just did. Okay, I think I have to pan out a little bit more. There you go. Okay, so the example I want you to do is, can you see it? Yeah. Limit as x approaches 5, 2 over x minus, you probably can't see that. Let's write it down here. Limit as x approaches 5, 2 over x minus 4 minus 2 over 1. I almost wrote that as a regular 2, but I didn't want to confuse you. Our regular 2 is just 2 over 1. Over x minus 5. Now I know some of y'all are already thinking. Here, let's zoom in. How do you get a common denominator with this? Well, here this denominator of 1, I can give that a 1 and multiply it, but it doesn't really make much of a difference. That's okay. Alright, now I also have x minus 4 and an x minus 4. That's what I'm going to do right there. Okay, that just gets you started. Alright, I want you to finish this for homework. And there's the whole example worked out. I need to hide that. There we go. Alright, I'm about to shut off, so pause it if you need to follow along with the example.